Hello there. Today we're going to solve these exercises actually, which are part of your revision. So we're going to start with the pivot table and pivot chart. And on the left, you can see some columns there starting from date, region, salesperson until revenue. So this is our data, and we're supposed to insert a pivot table by selecting all the fields except the date column. So it means we're going to include the region, salesperson, product, units sold, and revenue. And we're going to filter Alice Johnson's details and copy it to a different sheet and rename it as Alice. And only the region and the salesperson should be part of the rows. So basically, we just have to select our table, simple as this. Or you can also select just the first row and Control-Shift arrow down. Yeah, or as I said, you can just select the whole table. And insert. As you can see, the pivot table is the first part here. So we just have to click this one. Now, the moment you click OK, it's going to take you to another sheet. So let's click OK. So our original data is not going to be messy, otherwise it's going to be messy. So click OK. And we have to tick everything except the date. Well, if you're confused, you can go back to the question again and try to read and understand the question. You're going to select all the fields. It means all the titles except date. And you can go back there. So we have everything except the date. And as mentioned here, only the region and salesperson should be under the rows. So it means we have to move our product under the columns. It becomes like this, right? So as you can see, under our rows, we have only region and salesperson. And product is transferred to the column. Now, the units and the revenues are numbers. These are numerical values. So automatically, these values fall under the values. Okay, so we have to filter Alice Johnson's details. Okay, Alice Johnson actually belongs to the salesperson column. Okay, this is Alice Johnson. So as you can see here, it belongs to salesperson column. So it means that we have to move our salesperson to filters. Okay, and here you can see we have column A, salesperson, and we have all. So it means it is displaying all the salesperson. So what we're going to do is just to, select Alice Johnson and click OK. It's going to give us the details of this particular salesperson, Alice Johnson. So we have to copy this particular table, and we have to take the plus sign here to add a new sheet, and Control V to paste the details. So you can see that this is the details, or these are the details of the salesperson named as Alice Johnson. So let's rename this as Alice, as mentioned here. So this one is to be renamed as Alice. And sheet 1 is the answer of question 1. But we have to return this to the regional data. So this salesperson, we have to move this one back under the rows. Okay, so please don't forget this. We move this one temporarily under a filter section for us to filter here. Okay, but we have to move it back because this is the answer to the first question. Okay, so this is answer 1 of the pivot table, right? So this is for question 1. Let's proceed to the second question. So we are done here. The second question says we're going to insert a pivot table and pivot chart by selecting all the fields except the date and the region columns. And the total revenue should be expressed as an average. So we have to select the whole table and insert. This is the pivot table, but if you are going to insert a pivot table and pivot chart, you have to click insert and you have to open this part here. The second one is pivot chart and pivot table. Okay, so click OK. So you may review the question. We need to include everything except the date and the region. And we need to get the total revenue as well. And that should be expressed as an average, okay? So we are going to select everything except the date and the region. Okay, anyway, in reality, it's up to you which one you're going to select. Okay, you can play with this fields actually. It depends on your requirement. Now we need to change our revenue to mean or average. So we have to open the drop down arrow here and value field settings and change the sum to the mean or the average and click OK. So now you can see here that we have average revenue. So this means that this orange columns here, these are not totals of the revenues. These are average of revenues. For example, here we have widget A. This is the average until, close to 2000. The highest is the average of widget C, which is around 4,500. Okay, so this is the answer. So we can rename this one as answer 2 of the pivot. This is our answer 1. This is the filter data for Alice, and we have the answer of the second question. So we are done with question 6 actually. Number 6 is about a pivot table, filtering, and about a pivot table and a pivot chart. Number 7 actually is about, graphing functions and solving functions, okay? Finding the values when we have a piecewise defined function, for example, and here we have a linear function, number 4. Okay, the first one is a sine function. The A, B, C, and D are there already. We have 3, 5, 7, and 4. Our A is 3. Our B is after the sine or after the cosine. And our C is 7. Okay. And our D is 4. So the standard form actually is y equals A sine. Then we have bx plus c. Then we have plus d. So this is the general form. y equals a sine or a cosine. Okay. Then we have the quantity, we have the group of bx plus c, then outside is plus d. Please take note that if we don't have grouping symbols here, it means that our c is 0. Since we have the open and closed parentheses, we have complete set of values, a, b, c, and d. Okay? So this is how to find a, b, c, and d. The maximum, the formula is d plus the absolute value of a. So that is 4 plus 3 equals 7. And our minimum is d minus the absolute value of a. So we have 4 minus 3 is equal to 1. And we have the period. The period is equal to 360 over our absolute value of b. Okay? So if this was negative 5, for example, we have to take only positive value there. If a, for example, is negative 3, still we have to take positive 3 only, the absolute value. Okay? Now, if c is not equal to 0, like 7, for example, we have to solve first. Okay? If c is 0, we can start with 0 here directly. It will not affect our maximum and minimum. In this case, since we have complete set of values, c is 7 not equal to 0, we need to solve. We can take either the minimum or the maximum. Okay, so assuming we're going to take the maximum, that is 7. 7 equals, we're going to change our g of x to 7. Okay, and we have 3 sine. Okay, we have 5x plus 7 close plus 4. Okay, let me make this one bigger. All right. So basically, we change our g of x to any of these values. As I said, you can use either the minimum or maximum. It's easier to use the maximum, okay? So 7 equals 3 times sine, the whole quantity inside plus 4. So basically, it's like solving, an equation using a paper. So we have to transfer plus 4 to the other side. It becomes 7 minus 4 equals 3 sine 5x plus 7. Okay. Then, of course, 7 minus 4 is equal to 3 equals 3 sine 5x plus 7. That is because of 7 minus 4. Then, of course, we have to divide both sides by 3. So this is 3 over 3. And here, okay, if this happens, maybe you can put a space, 3 over 3. Okay. So space 3 over 3. So the date will not appear. And here space equals 3 sine 5x plus 7 divided by 3 also. Okay, so why did we divide both sides by 3? For us to cancel. So we can delete. So here we have 3 over 3. Is equal to 1. Okay, you can leave it like that. 1.00, it does not matter anyway. Or you can reduce also if you want. Okay. And here, 3 will be cancelled. So the remaining is space equals sine 5x plus 7. Okay. When you are not solving and you're using an equal sign plus any expression, you have to press space first before you key in the sign symbol. Otherwise, it will calculate and it's going to produce an error. Okay. Now, in mathematics, actually, we have to divide both sides by sine to solve the x. So this will become a sine 1. Okay. And here the remaining will be 5x plus 7. So sine here is cancelled because we divide both sides by sine. And here 1 over sine is a sine of 1. That is arc sine 1. Okay, it's the inverse of sine somehow. And here we can solve directly. We have a sine of 1 close. That is the value 5x plus 7. Here we can put space equals 5x plus 7. Here space equals 5x plus 7. So now we have to subtract these two. So equals this minus 7. Because we transfer 7 to the other side, space equals 5x. And divide both sides by 5. So equals this over 5. So this is the remaining. So 5 here is cancelled. So we divided both sides by 5 and we change this into degrees. So we have equals degrees of this. So this is the value, negative 62 point something. So we have to start here from negative 62 point something. So since we cannot write this exactly, because there are many digits there to the right, so press equal sign here and select this value and enter. Okay, so we have here the value, and then we're going to have equal sign equals this plus 0.25 times our period. Our period is 72 actually, this one. Why we use 0.25? That is 25%. So we are dividing our graph into quartiles actually. So we're going to have regular intervals. That's the purpose of that. And then we just have to drag it down until the end. Okay. Then the radians equals radians of the first, and then enter. So it's equal here. So this is actually in radian, this negative 1.0 something here. Of course, this one is only 0.86. If you're going to extend, it will be exactly like this by increasing the values. So why did we change the radians? Because Excel understands only radians. Okay, so next is to solve using the function here. So let's follow this function. We have equals 3 multiply sine. Okay, we have 5x times our first radian plus 7 plus 4, because you have plus 4 outside. Okay, as you can see, that is equal to the maximum. And drag it down. You have all the values here. So now you select the last two columns. Insert this one here, scatter plus the second one. Okay. So this is our graph. And one period is from here to here, or from here to here. Okay. Or from here until here. That is one period. So we don't have any x-intercepts. So no x-intercepts. Because this is our x line here. As you can see, our graph has a minimum of 1. You can select the points actually, right-click, data labels. It's going to add the numbers there. So our lowest is 1. It means that it's not going to touch our x-axis. This is our x-axis here. So we don't have any roots or no x-intercepts. Okay, so this is how to graph this particular function. Here we have a logarithmic function. So we have to start first with the domain. Our domain is after the log should not be equal to 0. Should be greater than 0. So 3x plus 6 greater than 0. Why? Because if 3x plus 6 is equal to 0 or negative, then it's going to create an error. So we transfer 6 to the other side, becomes negative 6. We divide both sides by 3. So this will be cancelled, x is greater than. Then we solve this one here, negative 6 over 3. So the answer is negative 2. So x is greater than negative 2. On your test, for example, I want you to give me a value which is very close to this negative 2. So maybe we can have negative 1.99. It's up to you. You can have negative 1.98, any value close to this vicinity. Okay, negative 1.8, you can also try negative 1.75, negative 1.5, okay, negative 1.25, negative 1, 0, 1, you can have 2 here, 3. You can continue actually. You can keep on going. Center. Okay. Right, so let's solve now. Okay, so let's follow this. So we have equals log of 3 times x, this is our x, plus 6 close over log of 3. This is using the change base rule, right? So we have log 3x plus 6 over log of 3. We have to take only the first x, that is negative 1.99, very close to negative 2. So we need to take values to the right of negative 2 because greater than negative 2. And drag it to the right. So these are the values. Okay, so let's graph our data. Insert. Okay, this one, second one. So this is our graph. All right, so how to find the x-intercept here? This one. This part here. That is the x-intercept. This is the x line. So basically what we're going to do is to look at our function. We have f of x, that is your y. So y is equal to 0. 0 equals log of 3x plus 6 over log of 3. Okay? So we change our y to 0, or f of x is equal to 0, and we delete the log. These logs will be deleted. The remaining is 3. So we have to raise this one to the power of this, whatever is the number on the right. So 3 raised to the power of 0. So whatever is the base here, that should be raised to the power of this. And the remaining here is only 3x plus 6. 3 to the 0 is equal to 1. 1 equals space 3x plus 6. Here we have space equals 3x plus 6. You transfer 6 to the other side, that would be 1 minus 6. Negative 5, space equals 3x. So we divide both sides by 3. So we have negative 5 over 3. That is your x. So we can increase this one. So our x-intercept is negative 1.666. So let's stop, comma 0. Okay, so this one is negative 1.666 or negative 1.7 approximately. This point here, comma 0, because our y is 0. Okay, the next one here is an example of a piecewise defined function. So we have to create our function. We have t of x. This is about the tax. The income is x dollars. And these are the incomes, 2,000, 5,000, and 9,000. So using these incomes, we need to calculate their taxes based on the conditions here. So we have t of x, that's for the tax, equals, the first one is 5% of, so that is multiplication of the taxable income. Our income is x. And the condition there is not over 3,050. So it means from 0 less than or equal to x less than or equal to 3,050. Okay, so this means from 0 until 3,050. From 0, because if there is no income, it means 0. That's the lowest income. Second one is 153 plus 7% of excess over 3,050. So excess over is x minus. For example, the income is 5,000. Excess over 3,050 is 1,950. That is 5,000 minus 3,050, for example. So this is the excess over when we talk about 5,000, for example. Okay. So the condition here, we can transfer the condition here, is over 3,050. So 3,050 less than, we have x less than or equal to 7,600, because not over 7,600. It means until 7,600. Here there is no line, as you can see, because over 3,050, it means from 3050.0001 approximately. Okay, the last one is 471 plus 9% of excess over 7,600. And this is over 7,600. That is the condition here. So this is our function. We're going to insert this symbol. Okay, because these three functions are combined together. So this is like one whole function. So the first one is 2000. You have to find where it belongs. It belongs here because this is not over 3050. So for tax 1, this is for 2000. That will be equals 5% times 2000. $2,000 income. So the tax is 100. For the second one, we have 5,000. So this is the income, 5,000. We have to follow the second one. Yeah, above or over 3050, but not over 7,600. So we're going to use 153 plus 7% times we have 5,000 minus 3,050 and close. Okay, see, here the answer becomes percent. Change this to number from here. Okay, this could happen anytime. The answer could be expressed in a date, for example, or, you know, short date, percentage. So you have to change to number from here. So 89.5. Now for the income 3, we have 9,000. This is, of course, the third one is greater than 7,600. So we have 471 plus 9% times we have 9,000 minus 7,600. Okay, so we have to follow this function here. So again, we have to change this to number. So the answer is 597. So as you can see, the one with the lowest income has the lowest tax. So this one is fair. 597 is the tax of 9,000 because it is the highest. Okay. So this is how to solve this particular problem. The last one is an example of linear function. This one is piecewise defined function. Okay, this function here. That is piecewise defined function. Now the last one here is about linear function. A computer virus or the worm or malware grows starting from 4 computers. So it's starting from 4 and it's going to spread. increases by 20 computers every minute. How long will it take in hours to infect 3,500 computers in this network? So X equals the number of minutes. Okay, because you have every minute here. So our function is 20x plus 4, starting from 4. Okay, so 4 here is fixed, will not change. It is the starting point. Usually viruses will start from certain number of computers and then it's going to spread like a wildfire, you know? Even human viruses is going to start with a few number of people and it's going to spread immediately. So we have 20 computers every minute, so 20x. Every here we're going to use multiplication. Plus 4, that is starting from 4. Now, how long will it take? So this is about the x. So x is the question. And we have our v of x. We can use here v of x as our function name or notation, which stands for the virus, okay? So v of x is equal to 3,500. So it means v of x here is the number of computers infected by the virus. Number of computers or PCs affected by the virus. Or that is your y. This is equal to your y. So we have 3,500 equals 20x plus 4. It's moving there. Okay. We transfer plus 4 to the other side. It will become 3,500 minus 4 equals 20x. So this will be 3,500 minus 4. Space equals 20x. Then we divide both sides by 20 equals this over 20 to solve for x. So in hours, we have to divide this by 60 because 1 hour equals 60 minutes. So it means 2.9 hours, almost 3 hours. So to infect 3,500 computers, we have to wait until almost 3 hours. So that's the answer. So that's all for today. I'm going to continue later. I have answered EX6 about pivot table and pivot chart, and EX7 about sine function, logarithmic function, and we have piecewise defined function here. Number 3, where we have different conditions, and we have here our linear function. Linear function here because we have 20x plus 4. The highest exponent of x is 1. Okay? So bye for now. Until the next time. Bye-bye.